Hi everyone. For this question, they ask, show that the iteration formula for finding the square root of any positive number p, as stated here, is a special form from Newton-Raphson iteration. Hence, means using this formula, apply the formula to find the square root of 3. Give your answer correct to 4 decimal. So for the first part, we're going to find the square root of positive number is a special form from our Newton-Raphson method as stated here. So first, in order to find the square root of positive number p means x will be equal to square root of p. Then from here we have to form out our function where square root function, we move it to the left hand side, it will give us a square function. So finally our function will be a quadratic function. So from here, in order to apply our Newton-Raphson iteration, we need to find the first derivative of the function. So differentiate x squared, we get 2x. Differentiate p, a constant, we get 0. Then we substitute into our Newton-Raphson method formula where xn plus 1 will be equals to Sn minus the function which is Sn squared minus p over the first derivative function which is 2Sn. So from here we have to simplify and show it has special form as stated in the questions. So for this we can get same to the denominator. So where this term is going to multiply with 2Sn, it will become 2Sn squared. Then we expand for this negative. Then we factorize 1 over 2 from the function. And then we can notice that 2Sn squared minus Sn squared, we were having 1Sn squared. Then we simplify the division Sn squared over Sn, we have Sn. Then for the another part, p over Sn. So this is the special form of Newton-Raphson method iteration. So by using this formula, we're going to apply finding the square root of 3. So when you're having a square root of 3, means that the p given here is 3. The positive value is 3. So our function here will be equal to x squared minus 3. So before we start using this formula, we need the initial value. Therefore, we are going to use our algebraic method to find out the first initial value. So we're going to find out the value here where x equals to 1. This is negative. And then when x equals to 2, so this is positive. So from algebraic method, we know that it having at least one root between interval 1 and 2. So state out our conclusion. So from this algebraic method, we can start with our initial value, which is the roots fall in between 1 and 2. Our initial value, we can start with 1.5. Then we can find our first approximation using this special form, Newton-Raphson iteration. Where p is 3. So we can key in our formula inside our calculator. So we'll key in Sn as alpha x, p as 3. Then we press calculate. For the initial value, 1.5. So make sure we have a decimal here. Then we continue for second approximation. So the question requests us to correct to 4 decimal place. So in calculation, we will advance 2 decimals. Then continue. So notice that our approximation of x is repeated. So from here we can conclude for this nonlinear equation, the root is x equals to 1.7321, where here only we rounding to 4 decimal place as question request.